There are those who are touting bamboo as the material of the future. But is it really something we can use for woodworking? The question to me as a woodworker is this a good material for doing woodworking projects with? So I thought I'd find out. I've never worked with bamboo as a wood type material, and so I had to look into it, and I had to try working with it. So, the most common thing we see made out of bamboo these days is cutting boards, and they're all over the place. They're inexpensive, they're extremely tough and durable, and that's great, okay? If you look at the construction of this, what it's made up of is a bunch of strips of bamboo. We really can't call it wood because bamboo is a grass, not a wood. And the reason for that is that, bamboo is circular and it's hollow. So what they have to do is they cut it down and then they split it into like 8 or 16 sections, and they take those sections and they plane them and join them to turn them into square or rectangular strips. Then they take those and glue them together to make boards or make plywood. So we had this cutting board sitting around here, and here's some cutlery that's made out of bamboo. But I had to go looking for some bamboo plywood or bamboo boards that I could use. And I'll have to tell you, they're hard to find, but they are out there. Mostly what you can find is real thin bamboo, like we're talking like 3 to 5 millimeter thick sheets. Okay, that's great if you do something that's, say, laser engraved or something like that. But to build something, you need something thicker. So I ended up looking for bamboo plywood. And the only thing I was able to find was some 3/4 inch bamboo plywood. Now this is just a piece of it, actually. The board I bought was 8 inches wide by 30 inches long. That's what I was able to get, okay? And I've used that for the various experiments that I'm going to do here, and I also used it to build a small box just to see how it was to work with, because that's a concern. Now, this plywood, as opposed to this board, is made like plywood, the grain going in opposite directions. We have a top and a bottom veneer, each of which are about, well, they're really not a veneer, they're about 2 millimeters thick, okay? And then we have a central core that's going in the opposite direction. The central core is made of a bunch of strips that I'd say are about maybe 5 by 10 millimeters, okay? And they're all glued together, so it's a three layer. It's not a 5 or 7 layer like we would normally expect it to be. It's very dense, has very few voids, although I did find voids in it, and it actually looks pretty decent. Does it look like wood? Yes and no. To somebody who doesn't know, probably does look like wood. Now we find this type of material being used in a lot of different places. Like a lot of hardwood flooring today is actually bamboo. It's not hardwood. It's a laminate of different materials, and the very top layer is often bamboo. Makes for a very durable finish. And they can get bamboo to come out in different colors. They usually caramelize it in the oven. They cure it. The process, they're able to alter the color. But it's also, I suppose, possible to stain it. So what I've done is I've bought this piece of wood, and what we're going to do is take a look at it and see what we can do with it. Now, I'll have to say one thing, though. This bamboo plywood was not cheap. I paid like 35 bucks for a piece that's 8 inches by 30 inches, okay? That's expensive. That's a lot more expensive than any other plywood I buy. It's really more expensive than a lot of hardwoods, even exotic hardwoods. Although it is by no means as expensive as the most expensive. That works out to about $28 a board foot, which to me is an outlandish price. Okay, all right, but this is new. You know how it is when new things come out, they're expensive, and then after a while they get cheaper. So hopefully, if anyone really expects us to take bamboo plywood or bamboo board seriously as a woodworking material, hopefully they get the price down to where we can afford it. So let's take a look at this bamboo and let's see what it'll do for us. The first and most obvious concern is, how is this material to cut? So let's put it on table saw here and see how it cuts. I'm cutting both ripping and cross-cutting to see the results I get. And I find that, like many other woods, there's a little bit of tear out on the cross-cut. I know there's a lot of woodworkers that don't do hand planing anymore, but that is a real consideration. How is the wood for hand planing? So I went ahead and tried it out here using a Stanley No. 5. and it planes really smoothly, actually. It, like any dense, close-grained wood, it's a lot like planing maple. And then I flipped the board around, and I tried planing it from the other direction. The wood is extremely straight grain, and so as long as you cut it with the grain, you can go either direction, and you don't have any problem with splintering. One of the other machining operations that we commonly do with wood is to route it. And so I've got a 1/4-inch round over bit set in my trim router here, and I'm just going to route 2 edges, one so I'm going with the grain, one so I'm going across the grain. Of course, what that means is that when it comes to the core, I'll be going the opposite. But again, we're just looking to see how well the material handles it. So it looks like both edges came out pretty smooth. Now the cross grain, it does have a little more roughness because of the porosity of the material, but it's actually smoother than I would get if I was doing cross grain on a piece of pine. This will need some light sanding just to smooth it. The pine, I would probably have some rough surface there that would need heavier sanding. So one of the big questions in my mind is, what's this wood, or this wood, I guess we call it an engineered wood, like to work with? What's it like to assemble with? I'm going to go ahead and build some small project with it, but I also want to deal with it from just, like, let's put it pieces together. So I've just got a couple of, I've got an offcut piece here and this leftover piece, and I'm just going to put them together. In other words, what happens when I try, okay? I'm going to use both screws and small nails, like brads, and just see what it's like to put it together. So let's start with the brad. And I have to say, this is a little harder to nail through than your typical plywood or pine would be. Okay, my first nail went crooked on me, my second nail went in pretty well. So yeah, okay, it's a little hard to nail into, but not a big deal. What about screws? I'm going to do 2 screws here, and I'm using just regular, they call them decking screws or outdoor screws. They're essentially drywall screws that have got a paint coating on them. I'm going to drill one in with a pilot hole and one in without, okay? Okay, so here's my pilot hole, and I used a tapered bit for this so that I've got the countersink, I've got some clearance hole, and I've got some pilot hole. We'll go ahead and run that screw in. And that went in very well, okay? Nice and clean, no problems getting it in. Now I'll try running one in without the pilot hole and see what that does. Okay, I got a lot more resistance to the screw going in out of this plywood than I would have, say, regular softwood plywood. That screw is actually hot from the friction. As you could hear, the impact driver was really working to get it in. I did get it all the way down, but I did not get the bugle head flush, okay? It's actually sitting up about 1/16 of an inch. So the surface of this wood is considerably harder than what you would find if you were using regular softwood plywood. And I would say probably the same if you were trying to compare this to hardwood plywood, because really hardwood plywood is softwood plywood with a hardwood veneer on it, or any of the other engineered woods we use. About the only one I would say that might be as difficult for driving into as this would be applewood, okay? Sometimes called Baltic birch. They're basically the same material. So yes, you can assemble it. Clearly we need pilot holes. Then again, I recommend pilot holes anyway. So that's not a big problem. But the fact that it's hard to get them in tells me that it's a hard material, which means it's probably going to be a durable material as well. One of the concerns with our bamboo is how well does it accept stain? That's a legitimate concern because a lot of us stain projects. So I want to do a comparison test here between our bamboo, and I've got 2 other control pieces. This is just a piece of pine, and this is a piece of Luan plywood. And just to see how it does, I'm going to use the same stain in all 3. This is kind of I guess you would say a mid-tone reddish sort of a stain. It's called cognac. And I'm going to try and stain them all the same. and see how they come out. Now, I know that when you buy like hardwood flooring or I guess you'd say imitation hardwood flooring that's made out of bamboo, that it comes in a variety of different colors, which would tend to indicate that it has been stained. But from the way I understand it, they get those different colors by caramelizing the bamboo in the oven. There's sugars, natural sugars and starches in the bamboo which caramelize as it's cured in the oven. So if that's the case, we may not have a surface that accepts stain well. So we're going to find out. So I'm going to clean these off in the same order I put the stain on. This is our bamboo. Here's the pine. Now, pine is notorious for not staining well. It tends to come out blotchy. And here's our Luan, which tends to stain very evenly. So when we compare these three side by side, I've got our bamboo in the middle. It actually accepted the stain very, very well and came out looking better, definitely than the pine. And I wouldn't say better or worse than the Luan. It looks different. It's not as red as the Luan is, but the quality of stain is about equal. It does bring out the grain nicely in the bamboo, so we can stain this for whatever projects that we're trying to make. I put some samples in some water to soak about 19 hours ago. I did it yesterday before I called it quits. So what I've got is I've got a piece of our bamboo plywood, a piece of regular 1/2-inch plywood, just softwood plywood, a piece of pine. This is just looks like a piece of, well, it was probably 1x6 that's been cut down, and a piece of oak. This is a piece of oak. Looks like it's a 1 by something. Okay. So they've been sitting in about 3/4 of an inch of water for almost 20 hours. And what I'm looking for here is how much moisture absorption do we get. Now, we're going to get some moisture absorption no matter what, but I want to compare the moisture absorption of the bamboo to these other woods. In my thinking, because the structure, the cellular structure of the bamboo will get a lot of water in there, but we may not get a lot of expansion. And what water usually does, or moisture in general does to wood, is it causes it to expand. And if it expands, you know, we get a lot of problems with things coming apart because of expansion and contraction. So that's what I'm really looking for, is that kind of a comparison. So just so that I know how much expansion we get, I measured all these before we started out, okay? So I'm going to start off with the bamboo, and it measured 0.760, so it's 10 thousandths over the nominal, because it was supposed to be 3/4 before I started. Now, if we look at this side, we can see where the water has soaked in here, but it hasn't come up all the way. If we look at the ends, we can see it's come up a little higher on the ends. Of course, that's, you know, we're standing at end grain. I stood all these end grain. So let's see what we get here now. It's only gone from 760 to 769. So that's very little expansion. That's really good. That means that we get some really good dimensional stability with it. And that's nice to know. So here's our 1/2-inch softwood plywood. The only reason I didn't use 3/4 is because this is what I had available to me. This started out at 0.484 inches. And is now 0.527. So when we compare that, we've got, instead of 9 thousandths of an inch of expansion, we've got something around 27, 37, 43 thousandths. Okay, so that's 4.5 times as much swelling in the softwood plywood as we got in the bamboo. So that's interesting. Here's a piece of pine. And this pine, actually, the capillary action caused the water to wick all the way up to the top. The top of this is wet, just like the bottom is. Okay, this is the only one that did that the full length. It started out at 0.762, so it was 12 thousandths over the 3/4 inch nominal. Okay, and it is now 0.800, 0.762. 0.800. So we're looking at an expansion of 38 thousandths. So that's 4.5 times as bad as the bamboo, but not quite as bad as the softwood plywood, okay? And keep in mind, the softwood plywood was 1/2 inch. If it was 3/4 inch, we probably would have gotten more. And now here's our oak. And oak is a very open grain wood, so it's going to be interesting to see what this does. This started out right at 750 thousandths, right at 3/4 of an inch for its nominal size, and it is now 805, okay? So actually we got more expansion out of the oak, and this is just plain ordinary S4S oak like you'd buy it at Home Depot or Lowe's, okay? It actually expanded the most. The one that expanded the least was our bamboo plywood. So one of the good things then, I guess we can say about the bamboo is that although it absorbs water, we don't get anywhere near the expansion out of it that we do out of other types of wood. What does that mean to us? What that means is if we glue something together or assemble it with the bamboo, and even if it is exposed to moisture, it's going to remain much more dimensionally stable. So we're not going to get that huge amount of expansion and contraction that's going to cause glue joints to fail, that's going to cause fasteners to loosen up, that's going to cause cracks to form between boards. So from that viewpoint, yeah, the bamboo's got it beat. One of the things I've noticed here is that there are some voids in this plywood. And what it looks to me is like they've made sections of the core and then put them together and maybe not gotten them aligned. Where these voids are, they actually go all the way through, okay? So structurally, is that a big deal? It might be if we're trying to do something where we're spanning, because really the only strength is these outer layers, which are each about maybe 2 millimeters thick, okay? But the bulk of it is not strong. That would make a difference if we were doing something like trying to use this for subflooring, okay? But for the majority of the projects that we do as woodworkers, that probably isn't a big deal. I'm going to go ahead and glue some of these blocks together, and I'll glue them so that I'm getting, and I'm talking about the core here, long grain to long grain, and end grain to end grain, and we're going to see how strong it is as far as gluing is concerned. I've got pine blocks that are the same way that we're going to use as a comparison. In doing this, I want to make sure I get full coverage of the surface, because if I don't, then I'm leaving it weak. But I'm not putting so much glue on there that it's swimming in glue. According to the manufacturers of the glue, Titebond and other manufacturers of PVA glues, you only need about 6/1000ths of glue thickness. Now on the end grain I'm putting a little more glue, and that's mostly because end grain tends to soak up more glue, and so I'm making sure there's going to be enough there. I'll go ahead and clamp these, and we'll leave them sitting overnight to dry. One of my concerns about the bamboo is just how well does it glue. Now our standard PVA wood glue is designed to work by soaking into the pores of the wood. It has to soak in so it can bond. It really doesn't bond just with the surface, okay? Will the bamboo allow it to soak in and get that grip it needs? If not, what it means is everything we make out of bamboo using PVA wood glue is going to be weak. So I've got 4 samples here, 2 of bamboo and 2 of pine. I've done end grain and long grain, okay? Now, I've done these tests before between end grain and long grain in pine to see how strong it was. I've added my bamboo plywood, and of course, being plywood, I've got grain going both directions, right? So this piece is predominantly long grain, and this piece is predominantly end grain, because our core is a rather large core, and that's really what we're looking at, okay? Probably the first one to fail, unless the bamboo does, will be the long grain pine, because the pine itself will break long before the glue will. And with the long grain pine, or the end grain pine, it will find that the glue will have to break, and it'll take a lot more force to cause that. The question is, how's the bamboo going to stack up by comparison? Okay, now I don't have the fancy equipment that some people do where they can put in a press and apply pressure to see when it fails. I use a little simpler method. I use the hammer method, okay? Now I've got 2 different hammers here. I've got a 16-ounce ball peen, and I got a 3-pound sledge, okay? So we're going to try and be consistent in applying force with these hammers and see when they fail. Okay, we ready? So let's start off with our 16-pound. I'm just going to essentially drop it from a height of about 1 foot. Okay, they can all withstand that. Now we'll take the 3-pounder and we'll go from the same height. That's promising. That's not surprising. Yeah, that was the wood breaking and not the glue. Okay, I'm going to go higher now. Okay, in this case it was the glue and not the wood that broke, because we're breaking long grain is really hard to do. Both our pieces of bamboo are still doing good, so. All right, I'm obviously going to have to apply a little more force, so I'm going to put some swing into it instead of just dropping it this time. Wow, that one didn't want to break. Okay, so what we found is that, like the pine, the end grain of the bamboo is actually really strong. Okay, we got a much better glue joint. On our side grain piece here, it was the bamboo that broke and not the glue. Okay, so we have the same type of thing going on with the bamboo that we do with the pine. In other words, the glue is stronger than the bond of the wood fibers when we're talking about long grain. However, when we're talking about end grain, now it's really hard to break the grain of the wood, so therefore it's where does the wood fail, or I'm sorry, where does the glue itself fail? And it turns out that the end grain held up better than the side grain. So in reality, what I'm seeing from this is that the bamboo plywood's stronger than the pine. So if we have a choice and we're concerned about strength, I really don't think we have to worry about the strength of the glue joint when we're working with bamboo plywood or really even bamboo boards. Ultimately, one of the most important things about this plywood is how easy is it to work with? How easy can we make something? So I'm going to make just a simple wood box with mitered corners just to see how it is to work with. So first I'm going to make sure that my miter gauge is square to my blade. Okay, it is. Now I'm going to set my blade angle for a 45-degree cut. Okay. And I've got that sticking out a little too far, so we'll bring it down some. All right, then I want a reference here of some sort so I can make sure I get my pieces all the same size. Let's see, it's not going to be quite big enough. Let's go for a little bit bigger box. Something like that. Okay, so we want to cut 4 equal pieces here. Okay, so I'm going to glue my box together here, and I've gone ahead and put it on double-sided painter's tape, or not double-sided, just regular painter's tape. It's a common way of gluing boxes together. It's a really simple clamping method, works really well. So I'm noticing that the bamboo plywood here is soaking up the glue rather quickly. It's rather porous, and so it does soak up a lot of glue. That's something to keep in mind if you ever try working with this. Whoops. No, we don't want that corner to slip. Okay. And now we can just leave that to dry. So, I glued together this little box yesterday out of our plywood. And it was more about seeing how it was going to be to work with than it was having the box or seeing for example, how strong the box would be. Having never built anything out of bamboo, I wanted to see what it was like to work with. And we saw a lot of that with the cutting of it, and it cuts very well, I'll have to say. It was, as far as assembly, gluing this together was very much like gluing any other wood product together, whether hardwood or an engineering wood product. Looking at my corners here, they're really nice and tight. So everything worked out right. Now, there's one little problem. I don't have a bottom in it. I'm not going to worry about that right now. I'll deal with that later. It was more about putting it together. So it's obvious that it's workable, and that's important. We do have a little bit of issue with splintering, but we do with other products too. It's not like that's something that's specific to this product. I imagine the same things that we use to help prevent splintering with, say, plywood or any other wood will work with this. Putting painter's tape on our cut line, scoring the cut line, things like that would probably work just as well. Zero insert plate. I didn't use a zero insert plate on the table saw. So there are things like that which we could do, which would cut down on the splintering. The finished product looks good. It's a good looking material. So from the viewpoint of building something with it, it actually works out pretty well. So overall, I'd say the bamboo actually worked very well as a material to build with. It stains well, it retains the glue well, it fastens well, it cuts well. Overall, it's a good material. It's just got one big thing against it, and that's the price. You know, I mentioned that the board I bought worked out to $27 or $28 a board foot. The cutting board that I had sitting here at the introduction is actually cheaper than that. So apparently the wholesale price for bamboo boards and plywood is considerably lower than the retail price. Low enough that they can build things out of it. I mean, granted, they're simple things, and sell them to us for less than we can buy the material. Well, that gives me some hope that maybe sometime in the future that bamboo plywood, bamboo boards will be priced at a price point that they would be available to you and I at a reasonable price, and maybe an actual consideration for a replacement for normal plywood, pine, maybe some of the lower cost hardwoods. Now, does that mean I would switch over to it? I don't know. You know, looking at things a little differently and thinking about them a little differently. You can work it pretty much the same as you can pretty much any wood, at least from what I've been able to see. And so that's good, and that's in its favor. We've got the same end grain issue that we do with any plywood, and we'd probably have to deal with it the same way, in the sense of putting some sort of banding on the end grain, or trying to design things in such a way, like using miter joints so we're hiding the end grain, things like that. So, you know, but those are the types of things we deal with regularly anyway. By no means can I say I am ready to switch over, okay? But however, if the price comes down, I can see where I might want to use it for some projects. I think it's probably a very durable material from what I can see. And that durability would work out really well for, say, shop furniture and fixtures, okay? Even furniture for a family room or for a children's playroom. I can see some really good places for it. The fact that it doesn't really isn't affected much by water means it might be a great material to build, say, patio furniture out of. So there's some definite potential for it. We got to see what the market does. If the market is able to produce this type of material for us at a price that's reasonable for you and I to work with, I can see where it might be useful to start working with it. Add it to our arsenal along with the other materials that we use. Will it ever totally replace wood? I don't see that as a possibility. You're somewhat limited with bamboo. Granted, that grain is not spectacular. It looks all right. It's decent looking, but when I hold that next to a piece of walnut, and the figuring you can get walnut or olive wood or many other types of wood, and the beautiful grain patterns, no, this just doesn't stand up to them. It's much simpler. Okay. But we don't necessarily need fancy grain on every project. So yes, there's some real potential. The question is really not up to you and I. The question is really up to the people that are manufacturing the product. Are they going to produce it at a price that's affordable for us to use? And for that matter, are they going to produce it in sheets and pieces that are big enough to use? You know, that 8 by 30 inch piece that I bought isn't enough to do a whole lot. And I would hate to have to go out and buy half a dozen of those to be able to build a project, especially at the price. But even if the price was lower, okay, I'm limited to 30 inches long. I certainly can't build a tabletop that way. I can't build a buffet that way. I might be able to build a bookshelf if I only want it 30 inches wide and 8 inches deep, but we're limited that way. So yeah, the manufacturers and the people that are providing the material need to up their game if they really want to make it a reasonable material for us woodworkers to be interested in. But when they do, and when they get it there, and I'm pretty sure they will, I'd say it's a material that's worth using.